Hello, everyone. Thank you for joining us for another Microsoft Excel Toronto Meetup group. We are in November, so almost end of the year, and we will have another session soon. We are also planning on new stuff for you for the coming year, so stay tuned. We will be sending news soon on to your email if you are set up or subscribe to our email notifications. Otherwise, you will be seeing the new presentations, the new sessions coming up. Okay, so you know how this works. We are using, and apologies, we are using Teams, so you know you can use the chat, you can raise your hand when you have a question. I will be monitoring the chat and questions. There will be room for questions in between different sections of the presentation, or you can ask in the chat, and we will give those those questions to Owen when it's time. The video will be available in a few days, so the session is recorded. Be mindful of that. In a couple of days, the video will be made available. So if you don't consent being part of the recording in any way, audio, video, your chat participation, please disconnect and then you can catch up with the video recording. My apologies. So my name is Celia Alves. For those of you who don't know me, there are a lot of new members that just joined recently. About 200 new people joined in the last 2 weeks or so. And I'm guessing that's because there's a lot of interest in the Python topic. So welcome to the session. Welcome to our group. This meetup has been running these sessions monthly since 2019. Initially in person, now online. We have a different presenter every month and a different topic, usually related to Excel. And the way it works is in a couple of days, I will upload the video recording to our YouTube channel, and we will make the video available. We will send out an email saying, here's the video, the link for the video, here are the files. You can also access the files from previous sessions through the Meetup website. I am an Excel expert. I've been working with as an Excel business solutions developer for 8 years or so. I am currently working as a business analyst, and I've done different things in Excel. I have my own training program, and I've been an MVP for a couple of years as well now, and so it's been quite an interesting journey. Grania Duggan, she is not able to join us today. She's been with the group since session 1, and then she started to help us and is now part of the organizing team as well. Our next session and the last one of the year in December 11th will be with Dick Moffat. He was part of the organizing team when the group started. He has many, many years of experience as a consultant and the business solutions developer in Excel. He will be talking about using Excel as the data consolidation engine and the engine also to publishing data from any local or cloud source. So he will be talking about some of the solutions he's been putting together using different things and connecting data coming from different sources. If you are interested in learning and understanding what Excel can do and how things can be done in Excel, it's a very nice session to join. We are sponsored by Sheetcast, so thank you to Sheetcast. Sheetcast is an add-in for Excel that allows us to transform a spreadsheet into a web application. It's pretty amazing. Let me just mute the chat here. There's someone there with microphone on, and let me see. So I was saying Sheetcast is an add-in for Excel, and you can transform your Excel spreadsheets into web applications with that. We will have a session, not sure yet when, but we plan to bring a workshop kind of session about this add-in because it really does something that I haven't seen being possible with other applications. And all of a sudden, if you use Excel, you become a web developer as well without needing to code or anything like that. Um, so thank you to Sheetcast for sponsoring our meetup. And, okay, not getting my slide. Let me stop share. Apologies for that. You know what's happening? I put in a link, and so when I click on the slide, it goes to the URL of the of Sheetcast instead of moving on with the slide. So let me share again. And now talking about the Women in Excel group on LinkedIn. If you are a woman and you are looking for a group where you can um, discuss Excel in any ways. Maybe you are looking for opportunities to start presenting without a lot of pressure in a small group, in a small setting and a warm environment. This is a good way to start. You can have, you just look for Women in Excel on LinkedIn. I will be I will be posting all the links soon in the chat as well after I finish my presentation here. Active Cell is an event happening in a week or so. Owen, you are going to be there, right? I believe so.
I am going to be there, yes.
Yes, I'm going to be there as well. So we get to meet in person there.
Cool.
Yes, and for any of you who are still considering attending the event, feel free to use the coupon code there. You will get 10% off. I'm not sure if there are still tickets available, but you can still try. It includes 3 days with different master classes and conferences, and then we will also be watching and witnessing live the finals of the Excel's championship. So it will be quite exciting. And just you will get these slides deck at the end when I send out that email that I mentioned. You will have all this information there. There's a newsletter if you want to keep up with what's new in Excel. There's different resources about Excel. All these links will be available there. Our sessions are recorded and uploaded to our YouTube channel, as I mentioned before. And there's a coupon code there for my training program where I teach how to automate recurring Excel procedures in Excel using different components of Excel. And you can check that out as well. And enough talking, because we are here to learn from Owen. Owen, thank you so much for making yourself available and for accepting the invitation. So I've been following Owen for some time now on LinkedIn, and I know that he's putting great content there every day. So feel free to, and I do invite you to follow Owen on LinkedIn. And I invited Owen to present about Python because he's one of the people I know. He's probably one of the most knowledgeable people I know when it comes to Python in Excel, because not only he has been an expert in Excel in many ways and has worked with Excel for many years for his job and even for fun. But he's now also part of Anaconda's team, who is the company who partnering with Microsoft to make Python available in Excel. So who better person could we have to present about this topic with us? Again, thank you, Owen, for accepting the invitation. You have been in the data analytics space for many years. You have experience in leadership as well. So the stage is yours. Fill in the gaps to fill in anything I may have missed about you that you want to share. and just let us know what we can learn from you today.
Thank you.
Thank you, Owen.
Hello, everybody, and thanks for coming. I'm going to do my best to share with you what I know. We've only got about an hour, though, so don't expect to know everything by the end of the hour. But I do hope to show you the interface, some of the basics around data frames, a little bit about data visualization, and then I want to show you maybe 2 or 3 examples of more advanced things that can be done when you take the time to make them work correctly. So on that note, to begin with, I want to share with you just this example here. I had a thought the other day. I thought to myself, can I create a Power BI style KPI card using Python and Excel? And, you know, because we have generative AI now, that is actually super easy. So I crafted my prompt.
Owen, sorry to interrupt you. The microphone issue that I mentioned before is happening again, at least for me.
It's happening again. Okay.
Yeah, it's kind of going. The volume is up and down, up and down.
Up and down. Sorry. We switched to a different mic. Just let's not mess around. Oh, that's okay. So is this? Can you hear me now? Is this better?
It seems more stable. Yes.
Okay.
Thank you.
This is just the laptop one, so we'll put this expensive mic out of the way because that's useless. And I want to just tell you about this KPI card. And I thought to myself, can I create a KPI card with Python and Excel? And it turns out it's actually very doable. So I crafted my prompt and I got the AI to give me this class. And I will tell you about the Python editor in a minute, but this class is defined in this cell B2 in a Python cell. And it's got all this code that configures things, and you can parameterize the background color and the title color and all of that stuff, font sizes and all of that, and these lines, the formatting of the currency and whether it's bold or not, and whether to use a triangle or not, and whether it's red or green, and all kinds of things. And within about 5 minutes of thinking, can I create a KPI card? I had this code, and I had an example of the code that would actually configure it and put the data in there. So you can imagine, if it's this easy to just pass the word revenue as a title, to pass a value and a dollar prefix, to pass a calculated percentage change and a subtitle, if it's that easy to pass it into this class and produce this image, and this is just an image, then we can parameterize all of this stuff. Let's say we had a table that had the card title and the value and the percentage change and the subtitle. We could then have Python cells on every row of the table and create cards for every row of a table, and then copy and paste them and do whatever we want with these cards. But this is all created with Matplotlib, which is one of the main charting libraries in Python and in Python and Excel. So I wanted to show you that example as a kind of teaser of the kinds of things that you can do if you take the time to learn how to use this feature. So let's move on to the real content, which is over here. This is my Toronto XLS workbook, and I've got the Python editor open again, and I've got a slide here, and this slide was also created with Python and Excel. But this is asking the first question we should always ask: what is it? And it is a first-class feature of Excel. It's not just some weird thing that is added in, and that you'll kind of be able to ignore it for the coming years, because it will become embedded and more integrated. And over time, I'm sure we will see more and more features, add-ins, workbooks, calculation methods, and all kinds of things that leverage this new power in Excel. So if you're here because you're wondering whether you should bother learning it or learning how to use Python, my answer is emphatically yes. If you are serious about being an analyst or anyone who automates anything in Excel, the benefit of using Python for these tasks is that Python is, of course, not just in Excel. It is everywhere else as well. But I find Excel to be a really useful way to learn things, because it's got the grid, and the grid is a very intuitive interface, and that is borne out by the fact that Excel has 1 billion users. So all of these users love it because of the grid, and you guys probably love it because of the grid. It makes it very easy to see what you're doing, and the flow of information is very easy. So that's why I think Python in Excel is a great way to learn Python. And just to show you how I created this slide, I've got a table here which has the title, the subtitle, and the bullet points. And over here, I've got the colors of the title and the color of the bullet. I mean, I could put a bunch of other colors there as well, but just to give you an example. And then in this cell here, I am calling, first of all, pull the table into this slide table data frame. And then I'm pulling out those little bits of information from the table. First of all, the title, the subtitle, and then the bullets. And then I'm getting the color for the title and the bullet color, and I'm passing them into this create Excel slide method. I'm passing those as parameters or as arguments into that method, and that method is defined on this imports and definitions sheet. It's somewhat complicated because, you know, I didn't write it myself. I got it from an AI. You pass it into the method, it creates a class. The class creates a matplotlib image. And it adds the title in a specific position. It adds the line, it adds the bullets, and it adds the bullet text. If we've got some time at the end, I'll kind of walk through some elements of this class. But this is another example of maybe a use case for Python and Excel that maybe isn't immediately obvious when you think about what you're going to do with Python. So that's how I'm creating those charts. So that's Python and Excel. You write and run Python directly in the grid. It is completely integrated. The code is executed in an Azure, an isolated hypervisor container, which is kind of a fancy way of saying a secure, isolated computer in the Azure cloud. So your code goes up there and is completely separate from the internet, separate from everybody else's code, and the data that you send is separate from everybody else as well. Microsoft are very, very serious about that security guarantee. All of the calculation happens in Azure, and then the result of the code that you have executed is returned to the workbook and displayed in one of two ways. Because of this, you don't need to have Python installed on your computer. So if you have Excel, Microsoft 365 Excel, if you have that, you have Python, because the Python is executing in the container. Moving on, I have some data. This is just a sample of the data. And this data I downloaded from Kaggle, and it is some financial metrics for some stock market companies, some stock market symbols. And I'm not going to be doing any fancy calculations because I'm not a financial analyst. But I will show you some of the things that you can do with Python and Excel and I just picked a financial data set because I assume that a lot of people have a lot more knowledge about that kind of thing than I do. So this is just to show you what it looks like. This is a table, and I will show you how to connect to that now. I will share this workbook with all of the code in it. Absolutely. There's only one workbook that I'm not going to share with you. And that's the one with the word cloud, which we will only get to if we have time at the end. But everything else I will share with you.
People are also asking about the editor, but you will touch that. You will mention, yes. You explain that soon. Yeah.
Let's talk about the editor now. So the Python editor, let's talk about the interface. Python Excel is on the Formula tab of the ribbon. You have this Python button group, okay? You have this Insert Python button. Let's go. I'm having a bit of lag in Excel today. I'm kind of clicking away from it and it's not changing. So forgive me for that. You hit this Python button and it will create a Python cell like that. You can see that it's created a Python cell and it's opened this pane where there's some documentation, there's a tour, and there's some samples you can insert. But I've realized that I'm moving way too quickly and I didn't actually show you what a Python cell is, and I need to do that for this to make sense. Okay, so a Python cell is created by using the Excel worksheet function py. So we type equals py, and you can either press open bracket or you can press tab. And then when you do either of those things, it will put this PY and green box to the left of your cell. And you can see that it's done that in the formula bar as well. And when you see that, that means everything you write from that point onward in that cell is Python code. Okay, so I can say X equals 1 plus 1, and then X. One thing you should know about Python cells is the display value or the return value of that cell is whatever is returned by the last line in that cell. So in this example, I'm returning X. X has a value of 2. To execute that, I've pressed Control Enter. Pressing Enter alone puts you onto a new line where you can type more code. Control Enter executes the cell. Or pressing, if you're editing the cell, you can hit the check mark, but I don't think anyone would really do that. So that's how you create a Python cell. I'm going to show you what this PY thing means in a minute. And I'm going to show you the 2 different output modes in a minute. So that's a Python cell. When you create a Python cell like that, you can open the Python editor from the Python button group. And every Python cell in your workbook is accessible through this editor. I have a video on my YouTube channel which will explain it in more detail than I'm going to go into now. But suffice to say, you can play with these different options to select different selections of Python cells that you have available to you. At the moment, I've selected all sheets, selected Python cells. So I'm selecting cell E9, and it's showing me E9. It's showing me the code, and it's showing me the output. Similarly, over here, I'm selecting cell B2, and it's showing me the code for B2 plus the output for B2. Okay. So that's the Python editor. There's a whole lot more. We could do an entire presentation on the Python editor. But I recommend you watch that very short video. It's about 6 or 7 minutes on my YouTube channel. And then we can talk about it more in the future.
Is it already available in the current channel, Owen, do you know, or just the beta version of Excel?
They started rolling it out to the current channel 6 days ago.
Okay.
So a small percentage of people will have it in the current channel. If you want to guarantee it, you'd be better off signing up for the beta channel. But I think within a short time, everybody in the current channel will have it.
Yeah, if they already started to roll this out, it shouldn't take long for everyone to have it. Yeah. So as long as you have a Microsoft 365 subscription and you are on the current channel, which is most people where most subscribers are, you should get it soon if you don't have it yet.
Yes, exactly.
Thank you.
So I'm going to move on to a bit more. I'm going to move on to some examples in a minute. So let's just answer some questions. Do I have to do something in Excel to activate Python? No. If you have Microsoft 365, you should see these buttons. If you don't see these buttons and you are on the current channel with an enterprise license, I think, I'm not entirely sure of the licensing, but if you don't see them, go to Customize Ribbon and look in the Formulas tab in Customize Ribbon and add it from there. What other questions are there? You need to be on PC. Mac version does not have Python and Excel yet, but it will almost certainly be something that they are working on. And I am going to show you Anaconda code later, which you can use in Mac today. The Python engine is located in that Azure container that I spoke about earlier. So you don't have to install it. If I share a workbook with Python in Excel, backwards compatible users will be able to view the output of your cells, but they will not be able to recalculate them. I do hope I'm getting all of this right. There's so much to retain. Okay, I think that's it for questions for now. I'm going to move on. Let's move on to this. I'm clicking and it's not moving. Okay, let's move on to here.
Yes.
Which I was playing with earlier and didn't delete. Okay, so Python is all about data. Excel is all about data. You have to get data into the Python cell in order to work with it. the Python cell and the Python runtime in this Azure container that I spoke about has no access to the internet. So this is a security measure. You can only get data into the Python runtime via your workbook. And that is done in one of three ways. It's either a scalar, which you're looking at right now, some examples of scalars, or it's a range, a data frame, or a table, or it's a connection-only Power Query. I'm going to show you examples of all three. Scalar is maybe a word that's not familiar to most Excel users, but that's just a single value. Comes from math and physics. So it's a single value that scales up and down. And you can see I've got a Python cell in cell C5, and I'm using this Excel method to refer to B5. And that is pulling this value, this date, into the Python cell. Let's delete these and I'll show you how it works from scratch. And let's do it in the Python editor as well. Okay, so if I've used selected Python cells here and I'm not on a Python cell, it doesn't show me anything, but it does give me this button, add Python cell. So I'm going to do that. And what I'm going to do is create a variable, my value. Can you mute yourself, please? And then we can type Excel, and I'm going to say, okay, B5. So that will get the value that's in B5 into the variable, my value. So it has pulled it in, and it's got a date time with the date time number as well as its text representation. And you can see it's displayed here. That is a scalar. So it is literally a date time data type. And if I pull that formula down, it will do as it does with any other formula in Excel, and it will copy them down with relative references to the rows below. So this one is now referring to this cell, and it's returning that number. And this one is returning the text, and this one is referring to an error, so it's returning an error. If I select all of them, you can see that you can see all of them on the side here. So the next thing to show you is what happens when we click on this PY in the corner of the cell. This is a card view. If you've used data types like stocks or geography data types in Excel, you're probably familiar with card view. When you click that, it gives you some information about the value. So this one, you can see that the string representation of that value is midnight of the 27th of November. Its type is a date time, and the type name is a date time. And similarly here, the string value is a 5, the type is an integer, and the type name is int. Okay, so this is very basic information about the data in that cell. Additionally, you have this field selector, so I can select the type name and it tells me that it's an integer. Okay. Okay, so those are scalars. The next one is connection only query from Power Query. Now this is the most powerful one, I think, because with Power Query, you should be aware you can create queries that contain many tens or hundreds of millions of records. You don't necessarily want to load them into your workbook in order to work with the data. So I will create a Python cell equals py tab. And then I'm going to create a data frame. And I'm going to call it DF. And that is a convention more than anything else. You don't have to use that name. That's just a variable name. And the reason I'm calling it DF is because when you use this Excel method and you type quote here, you can see it's giving me a drop-down list of all the named ranges, tables, and queries in my file. So these ones with the brackets and the ellipsis in between are the queries. So if I select that query, press tab, it autofills. What that's going to do is it's going to get the 22,000 rows from that query and load it into that data frame. Press Control Enter to execute that. So that's the data frame. Now, hitting the PY on this Excel is not responding. Gives me something slightly different. It tells me it's a 22,077 times 15 column, 22,077 rows, 15 columns data frame. And it gives me a preview of the data. Okay. Additionally, if I use the field selector, I can select that array preview and spill it to the worksheet. I won't do that now because I've got some grouped rows here and I'm not sure what it's going to interfere with. And I've got the string representation, the type and the type name as I had before. So that's the data frame. And in the Python editor, you can see the preview of the data frame. So this is when you've got the Python object set to, with a Python output set to Python object. There are two options, Python object or Excel value. If it's set to Python object, it will return the object in the cell. So this is actually an entire data frame in a single cell. If I change it to Excel value, it will spill the 22,000 rows in that data frame to the workbook, to the worksheet. And then it will be a dynamic array, just like any other dynamic array, but it will be populated by this Python cell. I'm not going to do that right now. I will do that on another sheet in just a moment. So that's a connection only query from Power Query. Note that I have just referred to the query name. I haven't done anything else. And it has correctly identified the column names of this query. And it's given me this integer row number, which I'm going to talk about again in a minute. So that's connection only query from Power Query. I'll just get to the bottom of this sheet and then I'll answer any other questions. Table or range of multiple cells. So this is another very similar to the connection only query, but in this case, it's going to be a table. And this is the table I showed you on that data sheet earlier. Financial data indicators. Now look what happens when I do it this way. That's Control Enter to execute that. Look what's happened here. I've got 0, 1, 2, 3 on the column headers, which is no good. And the reason for that is because this is a structured reference, just like any other structured reference when you refer to a table in Excel. If you don't have this, it will not pull the headers. Okay, so when you have a structured reference like that, it is just the table, just the data in the table. It's not the headers. To get the headers when you're referring to a table, you need #all in square brackets, and you need to put headers equals true. Don't forget to execute it. Okay, so that's the data frame, and it's now got the right headers from the table. Okay, so remember that. If you're referring to a table, it must be a structured reference, the same as you would have in any formula. If you want to get the headers, you need this #all, and you need headers equals true. I'm going to delete that one because it's going to interfere with other things. Okay, and then the takeaways. This is another one of these charts that's built from a table. The takeaways are that there are 3 ways to pull data into your Python cells. This is jumping all over the place. Got so many panes open. Okay, you can connect to a single cell and return a scalar. You can connect to a connection-only query from Power Query, or you can connect to a table or range of multiple cells. Both of the bottom two will create a data frame by default, although there is a way to change that. It's not in the scope of this presentation. There is a video on my YouTube channel, as I will be saying a lot during this meeting. But generally speaking, you just get a value or you get a data frame. And once you've got your data in your Python cell, then you can do really cool things with it. So are there any questions at this point?
Yeah,
can we get data from
some questions there? Yeah, so
Yeah.
you're reading. Sorry, go ahead.
Could we get data from a spilled array using hash in the Excel name? Yes, because the hash spilled reference is the same as any other reference. It's a valid reference, and so the Excel method recognizes it as the full spilled array. So the answer is yes to that. Aditya, Microsoft didn't completely integrate Python with Power Query. I have a list in the data frame of Power Query, Python, and Excel. Can't access that list. I can't access that list. Is it a connection only list? Or is it
Owen is it is connection only.
okay. That's interesting. I didn't know that. So one thing I do know is if you have a Power Query and you load the Power Query to the workbook, so it's on a sheet, you cannot then refer to the query table in the Excel method. You have to refer to the query name itself. I didn't know that about lists, but that's very interesting. Those are the only questions for now. Okay, let's move on. Return values.
Owen, so just one thing about what you just said, referring to the query table and referring to the query name. Until recently, those two could have the same name. So going forward, I know Microsoft has been going back and forth on how to deal with that, but overall, we should have different names for those two things, right?
Let me show you. So here's the financial data indicators connection only query. This is that 22,000 query. If I load it to, hopefully this is not going to take too long, load it to a table on a new sheet. Am I going to regret this? I don't know.
Fingers crossed here.
I think Owen C means that if we are loading the data from our Excel to Power Query and we made some transformations. So what happens is in Power Query, the name will be same to the table name in Excel.
Yes. Yeah. So
the source table, but not the output table of the query.
So look, this is the query table. And if I go to create a new Python cell and then say Excel, oops. So the one that I just loaded is the table, which is this one here, because you can see it's got the table logo next to it.
And it's the same name as the query.
The query is this one, but if I select the query, you can see that it's prefixed it with underscore XLPQ dot.
Oh, okay.
Okay. And if I select the table, it doesn't. And note that it hasn't selected the header. Now, I haven't actually done this in a long time. It'll be interesting to see if it works. I don't think it will. We'll see if this loads, but I don't think it will. Okay, it did load. So they must have changed that because originally when you tried to connect to a query from a Power Query from the same workbook, it wouldn't work. But now it does. Good to know. But it has a different name. The return values. This is the one where I was going to talk about the Excel values versus the Python object. So in here, I've got DF equals my financial data indicators query. And you can see that it's a data frame. I've realized that I'm going to get rid of this because this is in the way. This is a data frame. Now I can change this to Excel value and it will say that it's busy, and then it will, because it's spilling 22,000 rows, it will take a minute. But you can see now that it's just a normal spilled range, and it works like any other normal spilled range, like that, right? So this you can do with this Python output, whatever you want, whatever you can do with any other spilled range. But if you don't want to always do that, you can set it to Python object and it can just exist in that cell as the data frame. You can change the output mode using this drop down next to the formula bar, or the same drop down is here in the Python editor. And the keyboard shortcut on Windows, if I remember correctly, is Control Alt Shift and M. Control-Alt-Shift-M. So that's probably the one that I use the most, Control-Alt-Shift-M. So I can switch back and forth between them. When it's a Python object, you have this card view, as I showed you previously, and you have the field selectors. Now, what's really cool, and I'm going to show you later, is that the card view is 100% configurable, although it's not a simple thing to do. But by default, you get this with the data frame, you get a preview. Now, I could add a load of other information in this card view, such as the number of rows, the number of columns. I could add some statistics about the columns. I could add the count of unique files, any number of things. And there is a way to configure all of that, as well as a way to configure all of the fields that are available in this field chooser. It's somewhat of an advanced topic, but it is good to know that it's possible. So those are the return values. So when we talk about Python object, it means it's in this mode where you've got the py next to it. And when we talk about Excel values, it means it's a spilled array or a spilled value. The formatting is a native Excel task. So Python is data. Python in Excel is about data only. It cannot change the state of the workbook. It can't color cells, can't create pivot tables, it can't create tables. It can take your data, do amazing calculations with it, and then return data to you. That data can be a value, it can be a range, a spilled array, it can be an image, it can be a bunch of different things, but it is still just data. And you spill it out in Excel cells, yes. You do not have to install Anaconda. Anaconda, I work for Anaconda. What Anaconda's part in this process is we provide the Python libraries that are in the Azure container that executes all of your Python code when you run Python in Excel cells. The reason that Microsoft work with Anaconda on that and don't just do it themselves is because Anaconda have a long history of securing and scanning for vulnerabilities, open source packages. So the Pandas library, which creates DataFrames, is an open source package. It is a very, very well supported package by big companies. There's no risk in Pandas, but there are smaller libraries which are produced by one person or two people. And what Anaconda does, one of the many things Anaconda does, is it scans these libraries for security vulnerabilities and provides a guarantee to Microsoft that the distribution of libraries provided to them are free of vulnerabilities and are safe to use in their enterprise product, Excel. So that is Anaconda's part in Python and Excel. You don't have to install anything. It is just part of the integration. The reason it's there is attribution, really. Just to show that we are part of the process. It's not anything dangerous or untoward or anything like that. You do need an active internet connection to work with Python in Excel. Anaconda code is something different. I will tell you about that in a minute. I would like to answer that question about VBA at the end, if that's okay, because that's kind of a longer answer. Okay, so the next thing I wanted to show you was working with data frames. I used a Python cell to get the unique stock symbols from that financial data indicators data frame. I copied and pasted them as values into this table, and then I used the stocks data type to create these, to convert them into stocks. And these are rich data types with the card view, just like the Python cell. And I added industry from that card view as a field picker, and the symbol again as from using the field picker. There are a bunch of others, but I just used two as an example. The point is that this table, for our purposes, this table represents a reference data set with additional information about these symbols that we might want to add to our financial data. So now we've got two, we're going to have two data frames and we're going to join them together. And you'll be hopefully pleased to see how easy it is to do that. But before we get into that, let's talk a bit more about data frames generally. Okay. First of all, we'll talk about execution order. Execution order in Python and Excel is in row major order. That means it will execute cell A1 first, and then B1, and then C1, and then all across the first row before coming down to the second row, and then going across the second row and the third row, and so on and so forth. It only does that for the cells that have Python cells in them. So it's not actually going through every single cell. It will first do cell B4, and then it will do cell B9, and then it will do cell B14, and so on. So when I say row major order, that's what I mean. But in addition to row major order, it's also executed in sheet major order, which is sheet major order is a term I just made up, but it's from left to right. So I can refer to any Python object created in the sheets to the left of my current sheet. And what that means is that in this cell B4, which is the first Python cell on this sheet, I can refer to DF because DF was the data frame that I created on a previous sheet. And I can refer to it just like that. And there it is. There's the data frame. Okay. I don't need to pull it in again because I'm referring to the object created in the previous cell. I will answer your question, Anthony, in a moment. So first of all, I want to talk about indexes. I think there's a lot of Python in Excel videos out there, and not many of them talk about indexes, but I think it's quite an important concept to understand when it comes to data frames. There are really two main indexes in a data frame. And confusingly, one of the indexes is called columns, and the other index is called index. So when we refer to the columns of a data frame, that is the column index, which in our terms, in Excel terms, that is the headers of the data frame. So in this example, I've taken the columns index from the data frame and put it in this variable cols, and then printed the name of that column index to show you that the name is none unless you give it a name. And then the last statement in the Python cell is the output. So this is the index. And the index is the headers. Okay. So that is the columns index. Now you can assign a name to the column index with df.columns.names equals, and then whatever name you want to give it. And if I do that and recalculate this cell, it now prints the column's name, which is column headers. The index remains the same. It just has a name now. Okay. So I've given the columns index a name. So when I want to refer to specific columns, I can pull those values out of the index, the columns index, or from this cols variable. Now let's talk about slicing. In Python, a very important concept is slicing. So we saw in this cell, we've got this index, and an index is a collection of items. In this case, it's a collection of strings, source name, column 1, revenue, and so on. And they are ordered, and each one of them has a position or an index within it. It has a positional index within that collection. So source name is at position 0 because it's the first one. Everything in Python is 0 indexed. So if you come across a list, data frame, set, a dictionary, the first item is 0, the next item is 1, and so on. So if I wanted to extract this revenue column, I would refer to the index at position 0, 1, 2. And let's look at a few examples of that. So first of all, this is how you define a slice. You give the starting position. So I'm starting at position 2. And then you want this is the value after the ending position, which is admittedly difficult to wrap your head around to begin with, but bear with me. So if I execute that, it's now returned the revenue column of the index, or revenue portion of the index. because I've asked for the slice starting at position 2 and ending at the position before position 3, which is just position 2. So that's not very helpful. Now, if I do position 2 to 4, that is going to give me those 2 columns. So that's a slice of 2 columns. Now I can use that slice to grab the columns from the data by using df.iloc, which is an index locator. And it has 2 parts. Before the comma is a row index slice, so to select what rows I want. And after the comma is the column index slice. So this slice, as we saw above, is those 2 columns, revenue and revenue growth. I'm not defining a row index, so I want all the rows. And doing so will return those 2 columns from that data frame, like that, okay? And you can see that it's returned a data frame, which is a slice of DF, but with just those columns and the index. I can also index by name if I want to. Did that execute? Yes, it's just incredibly fast. So I can index by name as well by typing the name into a list, and a list is indicated by these square brackets, and the items are separated by commas. So I've selected revenue and revenue growth with this loc function, which has, again, a row locator and a column locator. Okay. Now, one thing you might want to do is build something that allows someone to type the column names they want into some cells and have the code select whatever is typed into those cells. So here I have typed revenue and revenue growth. And here I have, apologies, all Python cells. Okay. For the current sheet. So B14, we're on B14. I am selecting the values from D14 and E14. I am then going to try and use those values in that loc function the same way that I did up here. You'll see that it doesn't work. And there's a good reason, but something important that you need to understand. So this has returned an array, a NumPy array. By default, because it's coming from a spreadsheet, it is a 2-dimensional array, even when it's only 1 row or 1 column or even 1 value. So you can tell it's a 2-dimensional array. I've printed it here, and which has printed out this value here. It's a 2-dimensional array. You can tell that because it's got 2 opening and closing brackets with the first set representing the row and the second set representing the columns within that row. So in order to use that as a slice, it needs to be flattened, i.e. it needs to be changed into a 1-dimensional array. And luckily, there is a method to flatten into a 1-dimensional array, which is just your array name and then dot and then flatten. Index is the row index. Yes, correct.
What is the shortcut that you are using to comment and then comment?
Oh, that is Control and //
Thank you.
And that is on my keyboard shortcuts cheat sheet that I created and have shared on LinkedIn a few times. I can send that file to you as well as this file and all the other files, and you can share it with the participants. Yeah. But there's a lot of keyboard shortcuts for the Python editor. It's basically VS Code. It's the same shortcuts as VS Code and the advanced formula environment because they all use the same component. So this now works because we've flattened the array and it's returned. So now I can change this to whatever column names I want, and it will change the output of this cell to be the columns that I've selected. So you can hopefully see that this is starting to build something that is similar to what you might do with the filter function and a dynamic columns selection with the filter function. We've run out of keyboard shortcuts. Yes, you're not wrong. Okay, so next we're going to look at some simple data cleaning. Looking at the time. Am I running out of time? Probably. Simple data cleaning. First of all, let's
You still have like 30 minutes.
Oh, good. So first of all, let's remind ourselves of what those columns were. So we've got source.name and column 1. And let's take a look at the data a little bit. Source.name is actually the file name. And column 1 is actually the stock symbol. Now it came in as column 1 because the raw data file was no good. Of course it isn't. It never is. So I want to rename those, and I can do those with the rename function. There are two ways to do it. You can either do it, you can assign a new list of names to the column. So you can say df.columns equals and then a list of column names, or you can rename specific columns with this rename function. And with the rename function, you have a columns parameter, and to that columns parameter, you pass a dictionary. And a dictionary, you'll know something is a dictionary because it is encapsulated by braces, and each element, which is separated by a comma, consists of a key and a value separated by a colon. So what this is saying is rename source.name to file name and rename column 1 to entity abbreviation, which actually I later decided was not the right name. And it should be simple. Now, if you want to just do df.rename, you can do that, but you must remember to use in place equals true so that it will actually modify the data frame in place. If you don't do that, you'll run df.rename and it won't rename the columns, and you'll be very confused, like I am on a daily basis, because I always forget about this. So that's one way to do it. And then the other way to do it is the sensible way, which is to reassign the result of your rename operation to the data frame that you're renaming. So df.rename columns equals source name to file name, column 1 to symbol, reassign it to df, and now df.columns has those better names. So file name and symbol. Okay, so that's very simple. It's a very simple task. Okay. Now, the file name happens to have the year embedded in it. You can see it's the first 4 characters of this first column. That is no use to us. So we need to do something about it. We can create a new column in a data frame very easily. We just put the data frame name and then square brackets. Oops. In square brackets, we give a new name for the new column we want to create. And whatever comes after the equal sign is how you calculate what you want to put in that column. Now, we could do an entire presentation or 5 on the different ways that you can assign values to columns in Pandas in data frames. As a simple example of what can be done, I can refer to the file name column, which I've renamed source.name to file name, refer to that column, and then I can use .str. And what that is an accessor. And when you hear someone talking about an accessor in Pandas, it means you are accessing the abilities of whatever that accessor gives you access to. So for this, it's giving you access to the string methods and string slicing. So in this example, I'm using file name, and then I'm slicing the file name on the first 4 characters. That in itself will just return a string, but I don't want a string, I want an integer. So I do as type int, and then that will create my year column. So now I have my file name column, my symbol column, and then on the right I have my year column, which contains numbers now, which is useful. So next, when you hear about a data frame index, it's talking about the row index. If you don't assign any columns to that index, by default, that index will be a range index, and it's printed here. And it literally is just integers starting from 0, going up to the number of rows that you have. Which, okay, that's fine. Maybe I want to get the 10th row or the 100th row or the 1000th row or whatever, or I want to sample, maybe. But if you're working with data when you need to refer to things by name, that might not be super useful. So what you can do is use set index. And set index allows you to pass a list of column names from your data frame as to be used as the row index for your data frame. So in this in this example, I know that my data, the granularity of my data is 1 row per year per stock symbol. So I must create a unique index. So year and symbol is a sufficient combination of columns to create an index for this data frame. So this has done 2 things. Well, I'm showing you 3 things here. First of all, what the index looked like before we set the index, which is the range index. When you set an index with multiple columns, it creates what's called a multi-index. And this is now the new index of the data frame, which means I can now select using that loc method or that iloc method previously by name instead of by value of these index values instead of by position. And then the data frame itself, when you've set columns to be the index, you'll notice that it has kind of separated those column names away from the other column names. So year and symbol are now part of the index, the row index of the data frame. But all that's very theoretical. So let's actually look at what you can do with it. It's taking a long time to update. Sorry about that. Yeah, it creates a multi-row index, exactly. So if I want to, I can select all the rows from 2014 using an index slice. Because it's a multi-index, I need to use an index slice. If it was just a single column index, I would just put the word 2014, the number 2014 in this loc method, and it would give me the rows for 2014. But because it's multi-index, I need to use an index slice, and I need to say, okay, I want from the first level of the index, which is the year, I want the rows for 2014. And from the second level of the index, which is the stock symbol, I want all the rows. And we saw previously that when we want all of the rows from a slice, we just put the colon without the beginning, without the end, which is essentially the same as saying, give me everything. So this this gives me all the rows for 2014. It is a kind of filtering. That's exactly what it is. So you can see because I've sliced on the year, and the year is the only value in this slice. It has not returned a year, but it has returned the symbol into the result of this operation. So this operation produces a data frame itself, and the index of this data frame is just symbol. So it's a single column index because I've sliced on year already and I've selected a single value. Similarly, probably doesn't surprise you to find out that if I want to just get Procter & Gamble for all years, I can again use an index slice and select Procter & Gamble for all years. Now it's returned just the rows for that one company. Okay, so those are slicing on rows. And then the last point about data frames I wanted to make was just about joining. We've got those two. We created that list of codes from the data types, the Excel data types, stocks data types. So I'm going to pull that table, the stocks table, remember with the hash all, because it's a structured reference. I'm going to pull that into a new data frame called DF stocks, remembering to put headers equals true, and I'm going to immediately set the index to symbol. What you should note then is that when you're using Excel, the Excel method like this, you can treat it as if it were a data frame, which means all of the properties and methods and exciting things that you can do with a data frame, you can put at the end of the Excel method, including set index. So this now means that symbol is the index of the DF stocks data frame. And you can see that the columns are stock and industry, and the row index is the symbol. And then the rest of this code is joining the main data frame, which has those 22,000 records. It's using df.join, and it's joining it on df_stocks using symbol. You can also check, you can also use what's it called? Method? I forget. I always forget. But there is a way to determine what type of join it will perform. The default join that it uses is a left join. You can also use df.merge. Sorry?
But when it's how.
It's how? Okay, thank you. Let's say inner. I think that might speed it up, maybe. Yeah, so you can use left, inner, right, and so on and so forth. So that has now returned this data frame, which has all the original columns from the main data frame, plus the stuff that we pulled in into the DF stocks data frame, which you will note includes this linked entity, as well as the industry column. So the takeaways on this sheet before I answer some questions are, with my slide builder, I know this seems incredibly simple. I mean, it might seem simple if you've done Python before, but maybe not if you haven't. But this is important stuff. Learning how to index data frames is probably the thing that is the most tedious, but the most important thing to learn. I wish this thing wouldn't keep popping open. So they have a columns index and an index, which is the row index. And we can slice either to select specific rows or columns. That thing just doesn't want to stay closed. And we can join on index fields or on column names. And one last point I want to make about joining, which I tried to do earlier and then I remembered it didn't work, is that if you have a single column index on both data frames, it doesn't work with multi-indexes, unfortunately. But if you have single column index on both data frames and the index is named the same thing, so if both of these data frames had a single column index called symbol, all I would need to do is that. It would just be df.join df stocks, and it would automatically realize that we want to join on the index. But because I've got a multi-index on df, I need to specify on, which is a shame, but that's the way it is. Okay, some questions? Yeah, I'm not trying to downplay anyone's understanding by saying things are simple. It seems simple after you understand it. It is certainly not simple before you understand it. I'm not saying that whatsoever. It took me a long time to wrap my head around all this. And I don't think you can learn Python in an hour or even 10 hours, but it is worth learning. Yes, you can use wildcards. So what you do, generally speaking, is you create what is called a mask. And a mask is think of it as a dynamic array that is the same length as your index. You know how you use the filter function, and the second argument of the filter function must return an array of true and false. That is a mask. It is a mask to filter the data. Indexing in data frames works the same way. So any expression, you can create a variable that creates a list of Boolean values of true and false that is the same length as the index that you want to slice. If you pass that list, that Boolean mask, into the slicing function, loc or iloc, or any of the number of other different functions you can slice with. If you pass that Boolean mask in there, it will work as if you had passed specific names or specific positions. So Boolean masking is another important topic to learn, but I'm not going to get into it because it's quite complicated and we don't have a lot of time. Scrolling up. Multi-index row index is not like group by. There is a df.groupby function, which is like group by. But again, that's a topic that's a bit too far for this. It's really useful. I suggest if you want to learn about Python, learn about df.groupby. It's really, really, really useful. Essentially, you pass a list of columns that you want to group by, and you give it a function to which you would then apply to the other columns. So in a simple example, group by year, sum the revenue, that kind of thing. Teach you Python in an hour. Yeah, sure. Thunking is absolutely possible in Python, where though I would love to talk about it, I'm not going to.
Did I see a post from you somewhere recently about it?
I'm
on
not,
your
yeah, probably.
website, maybe on your blog or something. I think
there was an example I
ran...
posted a while back where I was currying some Python functions and passing functions around as arguments into other functions, which is really fun in a kind of weird way. But many people will tell you it makes your code less readable. I disagree with those people. But anyway, let's move on, if that's okay.
That's available for someone to find it there. Yeah.
Yes, sure. So I'm going to show you this custom function. So we went through some steps in a bunch of different cells. Now you can do it that way. And if you've used a Jupyter notebook, it works top to bottom. You put some code and then you put some more code and you keep building your process cell after cell after cell. And you can do that in Python and Excel. And you can get very, very complicated. And you can also tie yourself up in knots and get very confused. So when you know what you're doing, you know what you want to do, the smart thing to do is to create a custom function. So that's what's happening on this sheet. This is what I was having a problem with earlier. So you're going to forgive me if it doesn't work straight away. Really having problems with this
taking its
Python
time.
editor. Yeah, I might just open the formula bar like this. Okay, now it's opening. It doesn't want to stay closed. Okay, let's just look at the code here in the formula bar. You can extend this, by the way, and I think it's Control Shift and U will pop it open and close it again. I don't think that's a Python specifically, but yes, this is a Python custom function. And this is just encapsulating the steps that we did on the previous sheet. So first thing I want to note is that to create a function, you use this def keyword and then you give it a function name and you put open and close parentheses. If you have parameters for your function, you put them inside the parentheses. Each parameter must have a name. It doesn't have to have this stuff here. This is just this is called a type hint. It's for people reading your code to think to know that you intend them to give a data frame into this source data parameter and a data frame into this stock data parameter. This is also a type hint to indicate to people reading your code that your function is intended to return a data frame. So whoever is consuming the output of your function should expect a data frame to come out of it. So you don't have to put type hints, but they're very useful. It's good practice. Okay, so the first thing I'm doing is I'm passing the source data and I'm making a copy of it. This is also a good practice because if I were to not make a copy of it and I were to just modify this source data, it would actually change the object outside of the function call. So you have to read up about passing arguments by reference as opposed to passing them by value. This is a concept in VBA, it's a concept in lots of programming languages, and it's a concept in Python. So as a general rule, my recommendation to you is if you're creating a function, modify only the variables that you create within that function. Do not modify variables that are outside of the function, because you can really confuse things. So I've created this variable, modified data, within the function. And I've just set it to a copy of the source data that I've passed as the argument. Then I've performed that rename that we did on the previous sheet. And then I've calculated the year that we did on the previous sheet. And then I'm doing that join. So I'm returning the join of the modified data with the stock data on the symbol column. So that is the return value of this function. So applying this function to those two data frames will return a new data frame with the stock metadata added to it. So that's that one. Oops. This cell here is just, again, starting over from these for these data frames. So my financial data is indicator and my stock metadata has two different data frames here and here. This is in cell B4. And then in cell B6, I am applying the function by passing those two data frames into it and assigning the result of that function. Remember, it returns a data frame to DF. And the result is what you can see here. I think I might have called head on that in here. Yeah, so it's only showing me the top 5 rows because I'm using this head function because I didn't want to spill 22,000 rows to the spreadsheet again. The point is that the result of that function creates a data frame that is the join of the two other data frames. So the original data frame goes to the column class and year is added in the function, and then stock and industry are added from the stock metadata. I need to take a drink. Okay, so that's a very simple example. Well, it's not super simple, but it's an example of what you can do with a custom function. Now I'm just going to very quickly go through Anaconda Toolbox, Anaconda code, and then it will be questions. I think what I'm going to do is close this workbook because it's causing me problems. In answer to your question, Mohammed, they are available to other sheets and cells in the workbook, providing they come after the cell where you've defined it, as I described earlier. And after is the diagonal kind of going down the rows. This is the one I wanted to show you for the toolbox. Okay. So I've got some data here. This is, I forget where I got it from. It's probably Contosa or some generic data set like that. But if you install the Anaconda Toolbox add-in, you can create charts from data very easily and very quickly. Python charts. We built this toolbox to support Python and Excel because we're partners with Microsoft, and also because people who are absolute beginners with charting with Python will find it quite challenging to begin with, I think. And so we have this visualization tool. We also have Anaconda Assistant, which is a Python optimized generative AI chat assistant. I'm not going to go into data sets and code snippets, but I would love to talk about those with you at some other time. So in one example, let's delete this. In one example, I can create a new chart by going into this visualizations tool and hit new chart. And let's say I want to create a distribution chart. So the first thing I do is I select my sales order table. I'm not going to write any code. I'm just going to create it using this. So let's say category name, no, unit price. And I'm going to color by category name. Let's have a look at the preview. The charts are seaborn charts, but the code is written with the tool. So I'm going to create a facet plot. A facet plot is when you have multiple small plots within the same plot. So in the grid column, I am going to choose year, I think. Is that what no, we'll see. So I've chosen year and category name as the column and row facets. If I look at my preview, it's starting to build a kind of sensible looking chart, which is the distribution of unit price based on the combinations of category and year. Okay, so that kind of looks okay, but I want it to be slightly different to that. I want to add grid lines. So I'll just add grid lines, and this should all be quite familiar to you. I'm going to take the left border off each facet because, you know, creating a chart from a UI is what Excel is all about. I'm going to turn the legend off because we only have one series in each facet. Okay, so this is the chart that it's created. So I'll create it in cell A1. And all of that clicking around has created this code. All of this, okay? So all of that clicking has created this Python code, put it in a Python cell, and executed it. And you can see the image there. And if I hit this button, now you can see a full-size version of the chart. Okay, so there's my chart. And that's all created without me writing any code. It's just clicking and telling it what I want to do. But if I want to edit the code, for example, in this particular chart, when you create a facet plot like this, there is a transparency to the bars of the histogram, which I'm not a fan of personally. Now, because I have some experience with this, I know that in order to get rid of transparency, I can change this distplot function call and add an alpha parameter to it and set it to 1. So it writes the code, but if I want to edit it and change it in any way that I see fit, I can do that. I can just click edit here, continue, and put alpha equals 1, and that will make the bars opaque. And I can hit apply, and it will recalculate the chart and rebuild the image. So now that's all written. I only really wrote one line of code to get to that point. Now that I've created that chart, it is now listed as a saved chart. So now when I close this workbook, if I reopen it, it will still be here, and I can open this again and make more changes if I want. I can also duplicate it by cloning. I can move it and delete it if I want. And as many charts as I want to create here, they will all be listed here. So that's really what I wanted to tell you about Anaconda Toolbox for now. I will absolutely give you a copy of this workbook. What we call a viz definition. This viz definition is saved in the workbook. An Excel add-in like this, it has storage associated with each file. It can write data to the storage for the file. So this viz definition is saved in the workbook.
Owen, for the AI assistant,
yes.
is it your recommended tool to get help with Python code, or you would prefer using other AI tools?
I use like 4 different AI tools on a daily basis. For personal things, I use ChatGPT. For work, I use something else, and I do sometimes use the assistant in Excel. But generally speaking, just because of my knowledge and my background, I don't really use AI that much to build AI, to build code for Excel. But it's very competent with Python for sure. And if you want to use it to work with your data, you just use this aggregate or summarize a table or range, and it will let you select my table, and then it gives me some options. Let's calculate the total revenue generated for each product name. Let me say 1, press enter. It's pretty quick, and it gives me the code for doing that. So earlier we talked about the group by function, or I mentioned it in passing, but another way to do it is with the pivot table function. And so in this example, it said, okay, I want to calculate the total revenue generated for each product name. There are no products in this table, so it kind of got that wrong. But I would need to put this, I would need to press play to put this in a Python cell, and then I would need to edit this to be the symbol column. But it would essentially create an aggregate of revenue, the sum of revenue by symbol.
Mm-hmm. Okay, thank you.
We cannot currently create personal.py, though. That is a great idea. I do like that a lot. The saved viz definitions are workbook specific. However, there is this code snippets feature, and the code snippets feature allows you to take the code that you have created anywhere and save it as a snippet, and then it becomes Anaconda Cloud account specific, and you can share it between workbooks, and you can share it with other people who have the toolbox, your colleagues, anybody really. So in my example, I created a custom data frame accessor and I saved it as a snippet, and it's quite complicated because it does some complicated stuff with data frames. But I saved it as a snippet so that whatever workbook I use, I can access it immediately and insert this snippet into a Python cell, and then it becomes available for that workbook. So in a way, that is kind of like the personal macro workbook. It's not exactly the same, but it is a way to have your code snippets accessible to you. And in addition to being able to save Python formulas here, I should also mention that you can save your favorite Excel functions and formulas here as well. So we are still working on integrating that with the name manager, but it works very well for formulas that you insert into the grid. Yes, ChatGPT is, in fact, yeah, ChatGPT is not the best at creating Excel formulas. It tends to use older functions, and they tend to be overly complicated for now. Copilot is probably your best bet for Excel formulas. That's been my experience. Okay, let me just show you one last thing, which I really love this. So I want to show it to you. It's a different workbook. Okay, so Anaconda code. Anaconda code is installed when you install the Anaconda Toolbox, and is accessible from this button here. And Anaconda code is another way to write and use Python in Excel. It is not Python in Excel. What Anaconda code does is it creates a Python environment in the add-in, and any code that you run with what we call Anaconda code cells instead of Python cells, any code that you run via an Anaconda code cell is executed right here locally in your local environment in the add-in. It uses a technology called PyScript, which embeds Python in HTML files. And since an Office add-in is essentially a web page, we can use PyScript to embed a Python environment in a web page, and we can embed it in the add-in. And because of that, we can do loads of cool stuff. And the really cool thing I want to show you is this example, which is how we have now created an ability to create user-defined functions in Anaconda code. So I've got this function here, which is portfolio analysis, and it follows a lot of the same rules that we spoke about earlier for functions. It's got a description of what it does. It's got some code and some logic, and essentially you pass it some stock history data, which I've got from the stock history function. You pass it that and a few other options, and it returns an analysis of the data that you've given it. However, because we've put this above it, this is called a decorator. If you have a function and you see a line above it with an @ symbol in front of it, that function has been decorated with functionality that makes it, that extends its usability in the current environment. So in this example, this portfolio analysis function, by being decorated UDF, is registered in Excel as an Excel function. And if you don't know what that means, don't worry, it will become clear immediately. So now I can just type equals and Anaconda. And now I've got Anaconda.portfolio analysis as an Excel function. And I can use it the same way I would any other Excel function, use a spilled array, and it's going to, when I press enter, it's going to run that Python function and do the analysis of my Apple Inc. stock history. And you can see that it's returned exactly what the function was designed to return, which is information about the data that was passed into it, as well as some metrics that I don't understand. But that is how you create a UDF in Anaconda code, and that is the last thing I wanted to talk about. So now it's time to have as many questions as you want. And yes, a user-defined function is very similar to how a VBA user-defined function works, except the code behind this one is Python and not VBA.
Would it go with the workbook? Someone else?
Yes, it goes with the workbook, but you will not be able to use it unless you have Anaconda code installed.
Yeah.
And you must have the environment running, so you must load the environment. Now I'm kind of talking about this with the engineering team who built this thing, about automatically starting the environment so you don't have to press that button every time you open it. But you do need to have the add-in installed in order for it to work.
Okay.
It's a Python function.
Other questions? Let us know. I do have one question. So I haven't worked with Python except for very basic examples. But I haven't worked with it. I haven't done any project or anything with it. The other day I was, but I'm getting more and more aware of what it can do, which is, it seems to be basically everything, as much as your imagination and as your knowledge goes with being able to make it happen with Python. The other day I was working on a project in Excel where related to timesheets, and I needed to return dates based on a starting date of a contract and indicating that it was bi-weekly. So the dates needed to go bi-weekly. And because of the spreadsheet being was referring to one unique month, I needed to be able to get which dates in that month would be part of that job. So anyways, I was able to get an answer using dynamic array functions, but at some point I was getting a little bit stuck and asking, I bet Python could do that for me.
Yeah.
The question is, how do I find which libraries and methods and whatnot? I guess I could just try AI and see what it comes up to, as long as I'm able to explain the case correctly and well enough. Hopefully AI will spit out something that I could try and use as a code for Python. But are there any other ways we can find which type of libraries and methods and modules or whatever in Python that could be useful for a certain situation?
So I would say that 90% of what you want to do in Excel in the beginning is going to be with NumPy and Pandas.
Mm-hmm.
These two. Most of it with Pandas, in fact. But like, for example, in that example that you gave, there is a function in Pandas that creates a date range. And you can create a date range, and then you can extract specific properties of each of the dates in that range. And then you can filter the date range in the same way you can slice the date range in the same way that I sliced that data frame earlier, for whatever calculation you see fit. So every 14 days, starting on a specific date, something like that. I think a very useful way to learn is to ask an AI, give it a very general idea of what you're trying to do, saying, hey, I want to create some dates and I need to create them every 2 weeks and I need it to start on this date, and get the code from the AI, but don't just leave it at that. Don't let it be, oh, it works, that's good enough. I personally think it's super important to study what it's doing and understand what it's doing. And then read the documentation, of course. And then just on the subject of documentation, I do want to just mention a few things about Python and Excel, if I may. So anything that you come across in Python and Excel, if you have questions about it, you can do help. So help on Pandas. You can type help. Okay. That's fun. Let's restart that. I've never seen that error before. Okay, that's not good. Let's try this one. pd.dataframe. So here's the help on the class DataFrame in the module pandas.core frame. So I can read all of this. This is an okay way to interact with it, but it's probably better to go to the website and read the documentation. I know that doesn't sound like fun, but that really is the most authoritative way to work. There's help, and then if you've probably seen my posts about this in the past, but if you type pip list in a Python cell, it will show you all the packages that are available from the Anaconda distribution that is shipped with Python and Excel. So what I have done in the past is taken all of these, copied them, say, okay, give me all of that, copy it, paste it into my chat with whichever AI, and say, these are the Python libraries I have available to me. Which of these libraries should I use if I want to perform this task? Like, I want to work with dates. What libraries should I use out of these? And then it will give you a short list. And then you might say, okay, that's great, but specifically, I want to calculate every 2 weeks. What should I do? And then it might give you an example of how to do that with pandas. So it's kind of like a structured filtering down of an answer.
Yeah, that's a good tip. In the end, we need more and more of AI until we get, at least if we are knowledgeable enough. Well, I guess it's with anything. I don't use much AI for Excel because I just go and do stuff myself, but other people do need it. So it's the same for Python for me.
Yep, and me. Yeah, so that was it. That was my presentation. I hope you enjoyed it. I am actually doing a variation, probably a bit slightly different to this one, as a webinar, which is published by Anaconda, and that will be on the 9th of January. It's free. May have mentioned that before. So the webinar, it will cover some of the same material, but there will be other material in it as well.
If you want to send the link for people to register there, I can include that on the email that goes out as well. Or if you want to share it now as well, feel free to do so.
I don't have it to hand, but look, if anyone's got 5 minutes, I wouldn't mind sharing one final example of something really awesome that can be done with Python and Excel.
Yes.
Is that okay?
Absolutely, yeah.
Okay, this is the one that I'm working on. I'm most excited about. So this is an example.
Some people guessed it. Word cloud.
This is an example. I mean, a word cloud. Okay, I'm not a huge fan of word clouds, to be honest. But the point of the example is not that it's a word cloud. The point of the example is to customize those cards that I told you about earlier. In this example, I'm importing some modules that can create word clouds. Okay, and I'm getting my Power Query as my data set as a data frame. And then I am filtering. I'm using this table as a way to filter my data frame. So this is kind of an example of the interactivity that you can introduce into your Python workflow. So I've created this parameters table, which is based on different columns in my data frame. So if I want to select reviews of these iPhones between rating 1 and 5, I would change this to min rating 1, max rating 5. Should I analyze the review description or the review titles or both, and so on and so forth. So that's all of this code here, is pulling that table into a data frame and then extracting from that data frame the different parameters. Then pulling my list of countries that I want to filter into a separate data frame. And then this is an example of one of those Boolean masks I was telling you about earlier. I'm saying, okay, if the rating score is less than or equal to the max rating, and the rating score is greater than or equal to the min rating, and the country is in this list of countries, and the is verified column is equal to this is verified variable, which is pulled out of this table. If all of those things are true, this mask will be true, otherwise it will be false. And I can pass the mask directly into this dfraw.loc locator, and it will filter the dfraw table into this df filtered data frame. So that creates a smaller data frame to analyze. This is just pulling, this is applying the filter of whether it's whether we're going to include the titles or the descriptions or both. And then we are joining them all into a single list of words to push into the data, into the word cloud. This is a custom stop word set. So this is to say there's a default set of stop words that you can remove from consideration from your word cloud. So things like the word the and at and on. You don't want those in the word cloud because they are essentially meaningless and without context. But in addition to that, you can add custom stop words. So in this case, these are iPhone reviews. So having the word iPhone in a word cloud about iPhone reviews is not particularly enlightening. So I've created a custom stop word list by unioning the list of words from this table with the standard stop words, and I've defined that as a custom stop word list. That is then passed into this word cloud method, and that creates a word cloud. So in the first instance, what the word cloud method returns is this word cloud object. Remember I talked about Python objects earlier. Let me zoom in. It returns a word cloud object, and it just says word cloud, and the card looks like this. It just gives me this weird Python string and the class name and the type name. Okay, so fine, great. I can now convert that into an image and I can show it on the sheet. But what's happened? What you can do is customize the way that card behaves. And you can customize it with code that looks a bit like this. I'm going to try and open the editor. I'm hoping it's going to work. Yeah, it did work. Okay, good. So there's a lot of code here, so I'm not going to explain all of it. But essentially, this JSON object defines, if you put this JSON object in a very specific dictionary in Python and Excel, it will change how Python and Excel displays the object that you want it to change. So in this example, I'm telling it that I want to change the word cloud object, and I want to use a Python logo, and I want to display a list of these properties and all of these different things. I won't go into detail, but the point is that you can change it. And then you can register. This is called a repr. Is a representation of the object. You can then register this repr with the object that you are registering, which is this word cloud wrapper, which is a wrapper around the word cloud, and the function that you want to use to register that repr, the function that defines the repr. After you've done all that, I'm not expecting anyone to follow what I'm saying, by the way. I'm just saying that with this code, which is like less than 75 lines, I'm able to change it from this, which is not very useful, to this, which is much more useful. So now I've put a custom title. I've put a collapsible section which has the image, which is also selectable from the field picker, and a list of the word frequencies or the weights for each word, which is selectable by a field picker here. And this spilled array here is pulled directly from that Python object using an Excel formula. Similarly, this image is pulled directly from that Python object using an Excel formula. And that is because of this custom repr. So you will no doubt hear more about custom reprs in the future, but it is an advanced topic, I do admit, but it does offer developers of Excel models a lot of flexibility in how they present their data to users. I really am going to stop talking now.
Sorry, I was muted. All good, Owen, and thank you for sharing all that and for being available.
I'm
I
happy
can
to talk about it.
see, yeah, I can see. I mean, this is a whole new world, right? When you start with Python, it's now the whole world of Excel has a whole new world inside of it, and it's just mind blowing. So I guess there is now a new specialization inside Excel that is born, that people who are very good at or can start to be very good at Python have another way of working and of looking at Excel problems and being able to solve them another different way. Should you really be showing a subliminal advert saying buy good Apple?
I don't know, maybe not.
There was a question before about VBA. I'm not sure if you
Yes.
want to address that.
Oh, I'm scrolling up to find it.
I guess the question was about can we scrap VBA once and for all now that we have Python and dynamic arrays and Power Query and all this other stuff available?
What future do you see for VBA? So the thing is, if your VBA code is solely for processing data, there's really no reason to use it unless you have very strict policies about where your data can go. But I would say, like, i.e., it can't go to the Azure container that calculates the Python code. However, if you are in a situation where your policy is so strict as to not allow that, then I would highly doubt you'd be in a situation where your policy wasn't so strict to disallow VBA as well, because VBA is more problematic.
Yeah, yeah.
But the thing about Python is it's just about data. So Excel, VBA can change the workbook in many ways, create charts, create pivot tables, create sheets, delete sheets, all kinds of things. Python cannot do those things.
And also VBA can work outside the workbook, right? VBA, you can create new workbooks, you can create folders, you can save as PDF, you can send out emails, you can do pretty much anything in your machine, in your system. So that Python does not do that. So the same thing you said for if VBA is for, you are using VBA to manipulate your data, that already applied for Power Query, right? Anything that is about transforming data, you can already do that. You now can do that with Power Query. And it's, for me, it's much easier. I like VBA. I learned VBA. I've been working a lot with VBA in the past few years. But from the moment I was able to use Power Query to transform data, I stopped using VBA. It doesn't make any sense. But then VBA can do all the other stuff that Power Query cannot do, like the things you were mentioning. It cannot write back to the source, or it cannot generate outputs outside of the workbook. So each different thing has its utility, I would say.
Agreed.
Yeah, although we do know that VBA is being targeted to be discarded, but I don't know how long it will take. For one, it does things that are cannot be done or easily with other tools. Some things that, for example, now can be done with Power Automate and things like that can be slower than it would be if they are done with VBA.
Yeah.
That's one thing. And the other thing is that regardless of what you choose, how you choose to going forward, there are all these legacy files supporting daily operations in many companies around the world.
Yeah.
Running on VBA, and until they are replaced with something else.
Yeah, exactly.
Yeah.
So as an example of why you might still need VBA, I created that slide generator class, which I admit, you wouldn't create slides in Excel unless you want to, right? You can do it. And yes, it is an image, but I wanted to be able to customize and parameterize the color of the title. But there is no way currently in Python for me to point a Python cell at a colored cell and return the background color of that cell. You can do that in VBA, and I ended up doing it with Office scripts. So now I can just create as many different colors in a range, select the range and run the script, and it will populate the cells with the hex code of those colors. And then I can pass the hex code into my Python code, and that will customize the appearance of my slide. The same goes for the plots that you create. If you decide to start creating Python plots in earnest, you can parameterize the colors, but they need to be like the RGB or the hex values for those colors.
Yeah, so Python is colorblind. That's where we are getting.
Yeah.
Okay. Yeah, so in the end, there's always something for VBA to come to the rescue. But less and less each day. I see VBA being used.
Yeah. Just Anthony's question about starting PY code with import pandas as PD is redundant. It is redundant, but it doesn't give you any performance impact because the Python and Excel engine is smart enough to know when a library is already imported, and it won't do it again. But on the formulas tab of the ribbon in the Python in Excel button group, there is an initialization button, and if you open that, it will show you all the libraries that are imported by default, and you do not need to import those yourself. So it's NumPy, Pandas, Matplotlib, Stats Models, Seaborn, and a few others. But yeah, the best advice I can give you is to explore and play around with it and see what it can do for you.
Michael is asking, VBA example will refresh all cover Python. I'm guessing would it be to recalculate?
It's the same as
Python.
Recalculating the sheet. If you calculate the sheet, it calculates the Python.
So it would be the calculate method, not the refresh all. I would say
yeah. I think refresh all is for queries.
For queries and pivot tables.
Right. Yes.
And there's this thing of the partial calculation that was added recently to Excel, where before you had the calculation manual or automatic, and then now you have something, I can't remember what the exact name is, but it's semi-automatic or partial or something like that.
Yeah, it's partial. Yeah. Yeah. So when you have lots and lots of Python and Excel cells, if you've set the workbook to automatic calculation, they will all calculate anytime anything is changed. Which if you've got lots of them and you're working with a lot of data, it can get a bit slow, as you saw. If you use partial calculation, you can avoid some of that to some degree, but you do need to be careful with it. And I tend not to use it because I'm not very careful.
Yeah, and then we forget.
Yeah, exactly. Well, the thing is, when you use partial calculation, if you recalculate just one sheet of Python cells, the other ones will be formatted as stale values, so I'll have a line through them.
Okay. There will be a different formatting on those cells that let us know that they are not calculated.
Yeah.
Yeah. Okay. Yeah. So that's another thing that people should know. People are saying thank you, thank you. Is there any other question that we are missing? If so, let us know so that we can wrap up. And in the meantime, I'm going to share my screen just so that you have the contact information for Owen there as well. Feel free to connect with him. And as I mentioned, we will be sending the information over in a couple of days. Is there any other thing you want to add, Owen, or how people can find you?
No. I mean, you can just connect with me on LinkedIn or follow on LinkedIn, and we can chat about stuff. And if you have questions specifically about Python and Excel, Anaconda Toolbox, and Anaconda Code, if you have any questions about any of that, you can just direct message me about it, and I will reply to you as quickly as possible.
Okay, thank you. All right, I think we are good.
Thank you, everybody.
This was great. This was great, Owen. Thank you so much.
Thanks. Bye.
And thank you everyone who joined us for this session, and looking forward to seeing you soon.
Bye.
Okay, have a good night. Bye-bye.